inequalities today. We're only going to get through a couple of them. We're not going to get through everything, which is okay. So, what we have is we have looked at where the model reaches the highest point, the maximum, the minimum, and we looked for the vertex when we did that. So whenever we said find the highest point, find the lowest point, we found the vertex of the model. We either used our calculator or we used the formula x equals the opposite of b over 2a. Now ultimately, do I care how you find the maximum or minimum? Not really, as long as you can find the value. All right, we also found where something hits the water, hits the ground. That was always by finding the roots of the x-intercept, or the roots of the quadratic, not the x-intercept. Given up on Monday. And we either do that by factoring or using our calculator. Okay, so today what we're doing is we're going to be making an inequality. We're going to look for where is the height higher than a value or lower than a value. So we're going to be putting the two things we've learned this unit together. So this graph comes back from day 1. We did this exact problem starting on day 1 of our notes. And it was talking about the height of a rocket. So the height of the rocket here was given by the equation -16 t squared plus 128. Oops, that's a flaw. It's resilient. Why? Now the question is, on what time interval is the rocket higher than 240 feet in the air? So what that visually looks like here is I want you to draw a line. You can use a color if you want or just your pencil. It doesn't matter. But I want you to draw a line at y equals 240. Because we are looking for where the rocket is above that pink line, right? For higher. Now, if I were writing an inequality for this problem, what symbol would I use to fill in the blank there? Bless you. What symbol would I use to represent higher than 240 feet? Greater than. Why would it not be greater than or equal to? Why greater than? Does it say it needs to be equal to 240 or just more than that value? More. Just more, so we use greater than. We illustrated it on our graph. Now, think about, this is similar to what we did last week. There's only this one little highlighted yellow section above that pink line. So when we do our interval in our solution here, will I have one part to the answer or two parts? One part. So what interval here? When I do set notation, and a couple of us, not many, but a couple people mixed up set notation and interval notation on their quiz. Set notation is curly brackets. What inequality would you write here to represent higher than 240? When do you start being higher? What time? 3 seconds. Until what time? 5. Good. And I guess I should be using t's here, but I already wrote x, so we'll just do x. So we have 3 is less than x is less than 5. That's the time interval that we are higher than 240. Now what do I write for interval notation? Parentheses or brackets? Parentheses, 3, 5. All right, pretty easy so far? Great. Now, what if I said on what time interval is the rocket lower than 140? And I'm better than this, but I was apparently off my game. This 240 here should be a 100. I'm sorry. I'm better than that. Oh. I do. I apologize. It's my one mistake for the day. So, if I'm now looking for where the rocket is lower than 100 feet, what symbol should I put in here? Less than. So when I look at my graph, again, I want to draw a line at 100 so I can visualize this here. Now, when I take a look at this graph, how many parts am I highlighting that are lower than 100 feet? 2 parts. So my answer is going to have 2 inequalities. Now, I want you to kind of hold back here before you write your answer. It's not exactly the same as what we did last week because this is an application problem. It's real life. So we have to think about real life constraints. Can you have negative time? No. Can you go, like our domain here starts at 0, right? You can't have negative time. And can you go past 8 seconds? No, because if I went out to like 10 seconds, my rocket would be burrowing underground, and that just doesn't make sense. So when I write my interval here, my set notation, I'll try to bring this up a little bit. When I write the interval on the left portion here, what time do I start that interval at? 0 until what time? 1. 0 until the time of 1 here. So my interval is going to have I don't know, I lost the word. But it'll look like this. 0 is less than x is less than 1. That's one part, right? There's no infinity this time. You're not just writing x is less than 1. We can only have a time interval from 0 to 1. Then I write the word or. And what interval now on this portion am I under 100 feet? 7 to 8. Right? So this one you can't go to infinity because it doesn't actually make sense. Yes?
Why are the 0 and 8?
I guess technically, you're right. You could put included there if you wanted to. I'm not going to worry too much about that. But yeah, you could include them because it is always under for 0. Okay. All right, so what interval would you write here? How would you write this in interval notation? 0 to 1, yep. And if you wanted to, you could put a square bracket here, 0 to 1, but the 1 has to have a parenthesis.
Why is that?
This one? Because if you're at 1, you are at exactly 100 feet. But we want to know where you're under 100 feet, not at 100 feet. So you can go up to 1, so like 0.9999999, but not 1.
So when it's the one part, like the first one, you have to use the parentheses. So when it's first, okay.
No. Parentheses have to do with the symbol that's right here. This is a strict inequality, so it gets parentheses. If it was less than or equal to, you would use square brackets. So then we use the word or, and then we write this inequality from 7 to 8. And I'll just use parentheses here so that I don't confuse you. Yes, I'm sorry. Told you I'm off my game right now. Off my game. Unit. Trace, just do parentheses. That's why I did that, not to confuse you. Okay. Union is or, upside down intersection is and.
So don't worry about the bracket.
No. No.
You
All right, next part. Okay, don't overthink it. Guys, settle down, please. Settle down. All right, next problem. This is probably the last one we'll get through today. Since Jason jumped off a cliff in Acapulco, do you guys know where Acapulco is? Do you know where that is?
Yeah. Where?
Like cliff jumping. It's like people do that on vacation. Like jump off a cliff into the ocean. It's not morbid problem. He's on vacation. Alright, he's jumping off a cliff. What I need you to do to start is to graph the function that models the path of Jason's height. So it has negative 16 squared plus 16t plus 40. I want you to take a minute. I gave you... Okay, we need to stop talking now, please. I gave you the window setting box, so graph the equation, put in the window settings, and then sketch the picture on your graph, and we will come back together after you've graphed that. Right? So it's, I already have it. Graphed there. Perfect. So it should look like that when you're done. And when you're done with that, you can graph it then on right there. I'm trying to save you some time by giving you the window settings here. They're on paper. Yeah. That has to do with like the velocity and like gravity and stuff. And if it's not negative 16, it's usually because we changed the numbers so that it gives you an answer. But yeah, it has to do with like actual gravitational forces.
Wait. I messed something up.
Double check. Did you put it squared in? Did you use a negative instead of a minus, or minus instead of a negative? Alright, so when I look at this graph, couple basic modeling questions just to get it back into your brain. What height did Jason jump from? 480. So this last number here is the starting value, 480 feet. What feature of the graph does that represent? The line intercept. Now, if you guys aren't sure like where 480 is, so let's graph write that on our paper real quick. We need to label our graph today because we're going to draw on it. 480 feet, I would say, is about a little less than about a 5-story building. So, like, that's at least 4 stories up. That's how tall the cliff is that Jason's jumping off of into the ocean. He's very brave. I don't think I'm that brave. So Jason's jumping off a 4-story cliff here. And how long does it take until Jason gets to his maximum height? So can you trace for me the vertex? What is the maximum? I'm not going to do it at the board because you guys should know how to do this at this point. But find the ordered pair for me so we can interpret the time he gets to the maximum height and what his highest height is. So what do you get? Bobby?
44.
That's the highest height. What's the time? 0.5. So it takes him 0.5 seconds, half a second into his jump, he's at 484 feet, which is the highest point that he gets to. Okay. And one more basic modeling question, and then we'll do the inequality. How many seconds until he hit the water? 6. Right, so we'll label that on our graph as well. So he hits the water, he's only jumping for 6 seconds. Now I'm going to have to do some scrolling here so that we can see the whole thing. But our question is, on what time interval is Jason's height higher than the cliff? Now the cliff here we said was 480 feet. So we want to figure out how long is Jason higher than 480 feet? And what symbol would we put in that inequality here to be higher than 40? Greater than. So we already graphed it on there. We need to write an inequality. So when I look at this graph, it looks like I'm looking at this little teeny tiny portion right up here. I know the left endpoint, right? What's the left endpoint in this time interval? 0. Do I know the right endpoint? Do I know this value, this x value? How would I find it? How can I use my calculator to help me? Maybe. What did I draw on here? I drew a line at 480, right? Maybe we should graph that line on our calculator. Because when I graph 480 here, y equals 480 on my second line, it'll graph it and I can find the point of intersection right here. So it's a little hard to see, but I want that right intersection point. So I'll do window 5. No, I don't. Second trace. I give up. Second trace 5, intersect. Come close-ish to that point of intersection. Enter 3 times. And it'll give you the ordered pair at 1,480. Did anyone not get 1,480 when you do it on your own calculator? So we have this point here is 1,480. So I highlighted one portion of my graph, correct? So what set notation should I write to say that Jason's higher than the cliff from 0 to 1 second? Yeah, 0 is less than x is less than 1. And what would be the interval notation here? Yep, parentheses 0 to 1. Okay. Now the next part says, on what time interval is Jason 50 feet or below? So if I'm writing an inequality, what inequality symbol would I use for 50 feet or below? Less than or equal to. Right? He could be 50 feet or less than 50. So if I go to my graph, let's sketch that real quick. So we're somewhere down here, y equals 50. And when I think about what part of the graph I'm looking at just that part right here that's going to highlight once it unfreezes. Why do I not highlight anything on the left-hand side? Why is it only going to be this part over here? But, yeah, it would be kind of like negative numbers, and he starts way up at 480. So in terms of before his jump, he's never lower than 50 feet. So we're going to do the same kind of process here. We're going to change that 480 to a 50. I'm going to graph it. We're again going to find the point of intersection. So I want you to do that yourself and then tell me, what's the ordered pair here? does he get to 50 feet? You guys trace that for me and tell me how many seconds? 5.7. Alright, so what interval, how should I write this in set notation? To say that he is under 550 feet. Where does he start being under 50 feet? 5.7. Now we need to use less than or equal to this time because I'm looking for 50 feet or under. And he stops being under 50 feet when he gets to the water, 60 seconds, or 6 seconds. What symbol should I use in interval notation? The bracket. Alright, so I'll do 5.7 to 6. Alright, last question is multiple choice here. The question asks us, on what time interval is Jason at least 300 feet in the air? Now, if I was writing the inequality here, so if I had this written out and you had to put this symbol in, what symbol would you use here for at least 300 feet? Greater than or equal to. So can I right away eliminate a couple of choices in my multiple choice? Yeah, I can eliminate A and B because they don't even have the right symbol. So I'm between C and D. So what I can do, I need to know, is it from 4 to 6 or 0 to 4? So really quick, it's not even going to be that much work. I can type, oh, darn it. Sorry. Plus, what's the equation? Plus 16, I know. Oh well. Okay, negative 16x squared plus 16x plus 480. Sorry. Here, change that to 300. Now when I look at my graph, when I'm looking at for at least 300, am I looking above or below that line? Above. So do you think that interval is from 4 to 6 seconds or 0 to 4 seconds? 0 to 4. I don't even have to trace it because 4 to 6 seconds would be this bottom half here. So we know that the answer has to be D. Right? So here's what I would like. I didn't get to the last problem, which is okay. All right, so the last problem, or last example here, we'll do together. So it has a tennis ball is thrown upwards from the top of a 30-foot high building. Its height is given by the model negative 16t squared plus 80t plus 30. Right? So first of all, it says find algebraically when the ball reaches its highest height. So if we're finding when something reaches the highest height, we're trying to find part of the maximum. And what we said on the first part of our notes here is when you're looking for the maximum, you want to use this formula, the opposite of b over 2a. So we're going to use that formula right here. In order to find the time, so really I'm going to write t equals the opposite of b over 2a, that you reach the highest point. Now, all right, so we have the opposite of b. B is 80, so we would have negative 80 over 2 times negative 16. So I'm going to put that into my calculator. So we'll take negative 80 divided by 2 times negative 16, which gives me 5 over 2, which is 2.5. I'm going to use the value of 2.5 seconds here. So we know that it's going to take 2.5 seconds to get to its highest point. And then what is the highest point? Well, in order to find the highest point, we need to put that 2.5 back into the function for time. So we'll have negative 16 times 2.5 squared plus 80 times 2.5 plus 30. So I'll type that into my calculator. Negative 16, sorry, negative, not minus, so I'll get 2.5 squared plus 80 times 2.5 plus 30. And we get that the highest height that this tennis ball reaches is 130 feet. Okay, so we know that the maximum happens 2.5 seconds into the throw, and it's 130 feet high. Now they want us to sketch a graph of this function. So this time I'm not giving you the window settings. We're going to need to discover those on our own. So we'll start here by at least typing the function into our calculator. So we'll start with negative 16x squared plus 80x plus 30. Now because I can see it here, but I want to zoom in a little bit. So I'm going to make my window, I'll keep negative 2, maybe my x max. It looks like 10 worked. That would work. So we'll keep it negative 2 to 10. Y min, I don't know. We don't have to, we can just start at 0. And my y max of 600 is definitely too big. Let's try 100 to start. And we can go by 5s. So 100 isn't tall enough. So let's make our window a little bit higher. Maybe 150. Y max of 150. And that seems to work. So let's write down the window that we used. We had x min from negative 2 to 10. We went by 1s. And our y scale was from 0 to 150. And we went by 5s. So our picture, when I look at this, I'm going to sketch that graph on my paper. So take a minute here. And that's roughly what my graph looks like. All right, now it says label the information you found in part A. So part A, we found the vertex, which was at 2.5, comma 130. Now it says, using your calculator, determine the amount of time that the ball stays in the air. That means what you're looking for is you're finding the x-intercept. Where does the ball come down and land on the ground? So the way we find the x-intercept on the calculator is by tracing the 0, option 2. So I'm going to take this cursor all the way down. Here we find a value above the axis, below. We hit enter and guess. And we get to about 5.4. It says to round to the nearest tenth, so 5.35 rounds to 5.4. Right, so we'll label that right here, 5.4, comma 0. And it's going to take, we'll write that over here, 5.4 seconds to reach the ground. So we throw the tennis ball up, and it hits the ground after 5.4 seconds. Now this next part says the tennis ball cannot be seen from the ground when it is at a height of more than 100 feet. So we're going to determine the time interval that we cannot see the tennis ball. Now it says write an inequality describing this situation, just like example 1 and 2. What that means is we want to write an inequality that looks like these. All right, we're going to include the quadratic equation, a symbol, and then the height we are comparing this to. Okay? So what this will be here is we start by writing, let's see if I can keep the screen. Oh, I won't be able to see it. But we're going to write this quadratic equation because that's the height. We're going to write that quadratic, a symbol, and the height we're comparing it to. So our quadratic equation here, we'll just rewrite it, negative 16t squared plus 80t plus 30. So that's the equation we started with. And we want to know where we are more than or greater than 100 feet in the air. Now from this, let's look at our graph. Let's draw on the line, y equals 100. Now in order to solve this, we're going to need to know 2 points here, 2 points of intersection. We need our calculator for that, because remember, we are looking here where the tennis ball is above that green line. So once the highlighter shows up, it'll be highlighted for you. But we're looking above that green line. So on our calculator, we need to go back in and add a second equation, y equals, it showed us what we just wrote. We need to graph y equals 100. And when I graph that there, I'm going to need to do the intersection trace twice. So we'll second trace, option 5, intersect. Now I'll find the right one first here. I don't have to move the cursor yet. I'm just going to hit enter 3 times. And it tells me that that happens at about 3.9. Remember, we're doing a tenth here. 3.9, comma 100. So I'm going to label that on my graph. This is the point 3.9, 100. And the other ordered pair, I do need to move the cursor for this time. So I find my intersection. I have to bring this cursor closer to that left point of intersection. So over here is fine. Hit enter 3 times. And that value is at about 1.1, comma 100. All right. So we are above the value of 100 between 1.1 and 3.9 seconds. So my set notation here, remember that has a curly bracket, will be the time such that the time is in between 1.1, whoops, so I put the t or an x is okay, is less than 3.9. I use strict inequalities because we're looking for strictly above. Because I use those inequalities as well, I have to use parentheses in my interval notation. Now it says, use your answer from part D, what's the total amount of time that we are not able to see the tennis ball? So we want to know how long is it from 1.1 to 3.9 seconds. You can do that in your head, or you can take your calculator real quick and figure out that 3.9 seconds minus 1.1 gives you 2.8 total seconds that the ball is out of sight. Good. Now we're almost done with this one. It says, now over what time interval can the tennis ball be seen? Okay, so we're going to start by writing an inequality that will represent just like we did up here in part D. So write an inequality where you can see the tennis ball. So what we have here again is our inequality that we started with, the equation for the height. And this time I want to know if I can see the tennis ball. That means it's going to be less than or equal to 100 feet. Now I'm going to be equal to because I can't see it when it's more than 100, but it seems like I could see the tennis ball exactly equal to 100. So when I look at my graph, what I'm looking at here is the portion of the graph, and I'm going to wait for a highlighter so I can go in a different part, but that is underneath that line, y equals 100. Okay, so let me wait for this highlighter really quick here. Here we go. All right, so I'm looking at this part of the graph and this part of the graph. So I actually don't have to go back to my calculator, but I am going to point out to you here that I have, this is my y-intercept, 0, 30. I'm going from 0 to this time, from 0 to 1.1, and then again from 3.9 until I hit the ground down here at 5.4. So because there are two sections of my graph that are highlighted below the 100, I have to write two inequalities. So I'm going to write an inequality for this left part from 0 to 1.1. And when I do the set notation here, I need to use less than or equal to. And I'll put the word or, I'm going to write it underneath. And the other part of our inequality is from 3.9 to 5.4. All right. Now, when I do the interval here, I can use square brackets because I'll be less than or equal to. So it'll be 0 to 1.1 union 3.9, comma 5.4. Okay. Now it says, what's the total amount of time that the ball can be seen? All right, so we have to do a little math here. We have from 0 to 1.1 is 1.1 seconds, and 3.9 to 5.4 will be, if you don't know, I do know, but I'm going to show you, 1.5 seconds. So when you add those up, it looks like a total of 2.6 seconds you can see the tennis ball. So you can see the tennis ball for 2.6 seconds. You cannot see it for 2.8 seconds. All right, go ahead and try the practice. If you need any other help, ask your teacher.